Hello everyone, this is Mr. Kozlowski and welcome to Learning Target 3, our final learning target of Unit 7. And today what we're going to be talking about is chemical bonding. So, Learning Target 3, students will be able to apply different models of atom behavior, dot diagrams, ions, etc., to predict and describe the bonding of atoms and polyatomic groups. So basically what you're going to be given is using dot diagrams and also understanding of ions and ionic charge to determine what types of bonds are taking place and how these chemical bonds do take place. And you'll have to determine whether or not it's covalent or ionic bonding, which I'll explain here in just a little bit. So bonding, what is it? Well, basically a bond forms, a chemical bond will form between two atoms that are able to bond. And this is due to the concept of what we call happy atoms. So please understand that when we say happy atoms, we are referring to their outer energy level being full of electrons. And we talked about this as well as with the rule of octet. And it's basically the same thing, that atoms are going to basically give up or take away electrons in order to be happy. And what we mean by happy is stable versus non-stable. And atoms, what they do is they will use valence electrons for the bonding to occur. And we mentioned this in previous learning targets, that valence electrons are very important in determining chemistry, for that matter. What types of reactions take place and what chemicals are going to bond is because of valence electrons. So basically, if we look, it asks you to predict what will happen with sodium and fluorine. Here we got a picture of sodium, which has 11 total electrons, 2 filled shells or energy levels, and 1 extra electron on the outside. Here we have fluorine. Fluorine has 9 total electrons, 1 filled shell, and 1 missing electron from a full 8 on its outermost energy level. So what's going to happen? Well, basically, since sodium is looking to give up 1 electron, and fluorine is looking to gain 1 electron, they will work together to be happy. So like we said, remember that electrons want to have a full energy level, and they're going to take the path of least resistance in order to get to this stable state. So understand, electrons are either going to be given up or taken away in this case. So as a result, when that occurs, when an electron is transferred, and a chemical bond is going to form. So if we look, sodium has that 1 extra electron. Fluorine has a spot for it, because since it has 7 over here, 7 plus 1 is equal to 8. There's the rule of octet. Basically, that electron, sodium, will donate the electron to fluorine, and fluorine is now a happy atom. And due to that, a chemical bond will form between sodium and fluorine here. Now, when this happens, a chemical bond will form between the two atoms. And kind of bonding elements are like puzzle pieces, because only valence electrons can form bonds within a compound. And because of that, if there's 7 on one, there's 1 on the other, obviously they're going to bond together to form 8. If there's 3 on one and 5 on the other, those will bond together. And if they don't match up properly to get a full energy level, they're not going to form that chemical bond. So what types of bonding do occur between these different elements? Well, types of bonds that we have are covalent and ionic. So let's talk about covalent first. Covalent bonds are generally when electrons are shared between the atoms, and they will form between 2 nonmetals on the periodic table. And I'll show you where the metals and nonmetals are located on the periodic table here. Ionic bonds is what we've been referring to, are when electrons are donated. So this is what we've talked about in class. They are not shared, and they're generally formed between a metal and a non-metal. So what type of bond forms between sodium and fluorine? Well, sodium is a soft metal, soft reactive metal, and fluorine is a gas. And when they bond, one is a metal, one is a non-metal, that is going to be an ionic compound. So you're going to have to be able to distinguish between metal, non-metal, and determine if it's covalent and ionic bond just based off of that information. So if we look at metal versus nonmetals, where can they be found on the periodic table? Well, anything above or to the right of the staircase is equal to a nonmetal, and anything to the left is a metal. And if we look here, the staircase is more over here, but it also includes hydrogen as well. But the staircase starts on the left side of boron and kind of zigzags all the way down to the bottom. And anything to the right of that is considered a nonmetal, and anything to the left is a metal. This part in the middle, we have a special name for that. Those are called the transition metals. And we'll talk about the family metals over here and the family nonmetals over here. We'll talk more about those in class, but for our purposes for bonding, just know how to distinguish between a nonmetal and a metal on the periodic table. So let's look at covalent bonding. Again, covalent bonding is when the electrons are shared. So if we look here, we have the valence electrons for carbon. Carbon has 4 valence electrons, and here's a dot diagram. And this is how we're going to represent this moving forward in our models of the atom. Well, carbon is going to bond with hydrogen, except hydrogen only has 1 valence electron. So if we only used 1 atom of hydrogen, we're only going to be left with 1, 2, 3, 4, 5 electrons in its outer shell for carbon. So what happens is carbon actually will bond with 3 other ones, making a total of 4 hydrogens. And what happens is each of the open spots around carbon will allow for another electron to bond with it. So when those electrons are shared between hydrogen and carbon, a chemical bond will form here. There'll be 1 bond, 2 bonds, 3 bonds, 4 bonds, and CH4 is what the chemical formula would be for that. Now these are covalent bonds because essentially carbon and hydrogen are 2 nonmetals, so that would be a covalent bond. The opposite of that is an ionic bond. An ionic bond is where the electrons are not shared, or what we call transferred from one atom to the next. So here we have sodium. We have a dot diagram for sodium, and here we have chlorine. The chlorine has 7. Sodium has 1 valence electron. Sodium will most likely donate its valence electron and drop down to have a stable state. And when that donation occurs, there is going to be a chemical bond which links sodium and chlorine together. So that would be an ionic bond where the electrons are transferred. So to review, again, we're going to be able to explain chemical bonding, what it is. Again, chemical bonding is when electrons are shared or transferred, and basically a link between 2 atoms is formed. Number 2, distinguish between ionic and covalent bonding. Again, ionic bonds, electrons are transferred. Covalent bonds, electrons are shared. And then finally, you're going to use electron dot diagrams and the knowledge of ions to show ionic versus covalent bonding in this unit. Again, we'll get a lot of practice. If you have any questions, please let me know. And hope to see you guys doing well on this in class. Thanks. Bye.